Uh, Good evening. My name is Ayush Vastav, and I'm here to present a DSA assignment in front of you. That is DSA Quest 21, in which basically I have to solve any medium level LeetCode problem and explain you the approach what I have used, and then I have to submit the solution to see you the final solution. So let's start my video. Before that, let me share my screen with you. Yeah, so my screen is visible now. Now let's move on to the guidelines. It says that you are required to submit a video solution for any medium level lead code problem. As I have already mentioned you, that I have to basically explain a medium level lead code problem and submit the solution to see the final output. So the problem that I have chosen today is problem number 172, that is factorial trailing zeros. It is a medium level problem, but I will say that it is quite easy to solve because if you look at the topic of this problem, it's completely maths. No data structure or algorithm has been used here. Okay, simple data structure like integer has been used. That's not a thing. I would say that generally, totally pure maths has been used in the pure math concept has been used to solve this question. It says that you have given an integer n, return the number of trailing zeros in n factorial. So we all know what is factorial. If it is 3, 3 factorial is 3 into 2 into 1. So like 5 factorial is equals to 5 into 4 into 3 into 2 into 1. So that is my factorial, okay? And when I am given the number, I have to find how many zeros will that number, the factorial of that number will contain how many zeros. Like in this case, 3. When I'm calculating the factorial, it is 6. There are no zeros, okay? But when it's 5, the 5 factorial is 120, then there is 1 zero in the end. So I have to find how many zeros will be in the end of that, in the factor of that number. So for solving this problem, this is a very simple approach. What I have to do is that I'll simply start. We generally there is a math concept in which generally we understand that whenever how many zeros will the number contain depends upon how many five and twos are present in that particular number. Okay, now let's say um, I have to find in the term of, let's talk in the terms of factorial. So in 5 factorial, I can simply see that when we break it, we can simply see that 5 into 4 into 3 into 2 into 1. So there is one pair of 5 and 2, so there will be 1 0. Similarly, it completely depends upon how many pairs of 5 and 2 twos are present in that number or whatever it is, then there will be that much amount of zeros. But here we are only calculating the number of 5 divided by 5 because the frequency of 5 in the factorial of any number will always be lesser than the frequency of 2. What does that mean? Whenever the 5 is going to be in that factorial, let's say 5 into 4 into 3 into 2 into 1, when you break it, the factorial of that number, if it contains 5, then there is a surely chance that 2 will be also present in that because we continuously multiply it. So 2 and 4 is also there. So 4 equal to 2 into 2. So if we look at the 5 factorial, I can simply say there are 3 twos and only one 5. So frequency of 2 is always bigger than 5. So that is a general maths. And we only will look at how many 5 does that numbers contain. So what I'm going to do is that I am simply using an integer count that is initiated with 0. Then I'll start doing this operation till my n is greater than 0. So when I'm doing this, let's say this is 3. So when I'm n that is 3 equals to 3 divided by 5. So 3 divided by 5 is equal to 0.6. But it is an integer, so n will go to 0. So count plus n 0. So return count 0. Okay. We are looking at how many number of 5s are present in that factorial. Let's say this is 5. So n equals to 0, n greater than 0. Yes, 5 is greater than 0. Sorry. Yeah. So 5 equals to 5 divided by 5. Now 5 divided by 5 is 5, 1. So n becomes 1. And now count plus equals to n. So count 1 will be added to the count, and now count become 1. Now I can simply see that now count is 1. When we are again put 1 is greater than 0. When we again put 1 here, 1 divided by 5 equals to some 0.02 something. So that will not be added. That will be equal to 0. So we'll simply return count in the last step that was 1. So as I can see 1. Similarly, you can take any number. So let's say I have 10. Okay. So uh, when I do operation on 10, I can simply see that 10 is greater than 0. Yeah. So n equals to 10 divided by 5. So 10 divided by 5 is what? 2. Now n becomes 2. So count plus equals to 2. Okay. So count will be 2 because when again I will put 2 here. So it will become 0.520 is 5 0.4. So it will become equal to 0. So count will be equal to 2. So when you take the factorial of 10, the value we'll get is the amount of number of zeros you will get in that factorial value will be equal to 2. Uh, let's see that factorial of 10. What is it? It is 3628880. Now simply we can simply also find out that there are two zeros. So this is how this concept is working basically. It's a quite easier concept, but it was pure maths. That's why I think many maximum people are not able to solve it. Look, the acceptance is 43.1% only. So that's why it's a medium level problem. So yeah, was the whole solution. This is the most optimized or simple approach. I don't think so that there are any other approaches to solve this question. Or maybe there can be, but this is, I think, the most easy approach. Let me submit this solution to see the final output. Yeah, so it has been updated. As I can see that runtime is 0 millisecond, beats 100% use with Java. That means that the question is quite optimized and it has been solved. Let's see some other approaches if the people have done. Yeah, so look, this kind of approaches are also been done, but I think that the approach that I have used is the most basic approach, pure maths it is. So yeah, in this way, this problem has been solved. I hope you have understand it. Thank you very much for being here.